Okay, here we've got xenon tetrafluoride, a pretty exotic molecule. You've got xenon, a noble gas, that can somehow react with fluorine, forming covalent bonds. It can use its electrons to share with the very electronegative fluorine. So let's use the Lewis dot diagram to figure out how it does that. So, okay, xenon tetrafluoride, next step, of course, is to find the number of valence electrons in this covalent molecule, and we just use our periodic table and find out where xenon is here in our 8 valence electron row and fluorine in our 7 valence electron row. So using that, we can say, okay, we've got one xenon, which ends up having 8 valence electrons. A lot of, well, its top shelf has that maximum of 8, and now we have 4 fluorines, each with 7 electrons, giving us 28 extra valence electrons. So this is going to be rich in electrons, a lot of them. And if we add everything together, we're going to have to deal with 36 electrons. They're going to be in pairs, so there's going to be 18 pairs of electrons floating around one way or another. A first step, of course, is to get our structure set up here with xenon as our central atom. And then, of course, we have our fluorines floating around it that we're going to bind together by sharing electrons. So that's our next step, which is to share some electrons. Here we draw this line to show a pair of electrons that fluorine is being attracted to and xenon is being attracted to. And we have 1, 2, 3, 4 pairs of electrons, a total of 28. So that whittles down our total of 36 electrons. We've taken care of 4 pairs of them, and we have 28 more to deal with. Now, since the xenon has its 4 pairs of electrons in these bonds, these extra electrons are going to be put onto our surrounding atoms. That's our next step. First step is to put in the shared pairs of electrons, and next is to use our extra electrons around here to complete the octets of our surrounding atoms, unless there's a hydrogen. So we do that by adding 3 more pairs of electrons, 6 for each one of these fluorines. So we're going to have a 6, 12, 18, 24. There we go. Drawn very, very quickly, our 24 electrons. So we'll subtract them from our total. And we've eliminated most of the electrons, but there are 4 leftover electrons. Now, if you have leftover electrons, once you've completed the octets of your surrounding atoms, the next rule is that these electrons will be attracted to the central atom. So we are going to put them into our central atom, and we put them in as pairs again. Shared pairs, well, in this case, unshared pairs of electrons, because they are just hanging out here. They're attracted to the nucleus, these xenons, and they're going to be just hanging out there. So we have 2 types of electrons in our central atom here. We've got our shared pairs, shared between xenon and fluorine. We could have written them as just 2 electrons, but I like writing these bonds down. And, of course, we don't have any electrons left over. So this would be our Lewis dot structure for xenon tetrafluoride. This wasn't made until relatively recently, but this Lewis dot system, which was developed many, many years ago, correctly predicts what the xenon tetrafluoride is going to be like in terms of covalent bonding. Experimentally, we find out this is what happens. So it's a really, really, really neat bond. I mean, with a pencil paper in a couple of seconds, here you can come up with our xenon tetrafluoride. Now, this classification system is important because it's going to help us later with the shapes of molecules. We have our single bonds here. The single bonds are called sigma bonds, shared pairs of electrons. So we have 1, 2, 3, 4 sigma bonds, and we have 2 extra pairs of electrons here which are going to affect the shape of this molecule. These are 2 unshared pairs of electrons. So this central atom has, in effect, 6 domains, 6 sets of spaces that are going to determine the geometry. So the steric number for this is 6, and that steric number is going to come in handy. Well, there we go. We've described this really, really exotic xenon tetrafluoride.